Hello everyone, welcome to SCI-EASE. In this video, I am taking up very important topic, and the topic is how are electrons distributed in different orbits. The distribution of the electrons in different orbits or the energy levels that is suggested by Bohr and Bury. Okay, they set up certain rules. Okay, they set up certain rules for writing the number of the electrons in different shells or orbits or energy levels. Okay, so the first rule is very important. All the rules, they are very important. First rule is the maximum number of the electrons present in the shell is given by the formula 2n square, where n is the orbit number. Okay, where n is the orbit number. First 1, 2, 3, so on, or K, L, M, so on. Okay, so when n is equal to 1, when n that is equal to 1, substituting the value 1 into 1 square, 2 into 1 square, 2 into 1 square, what will be the result? 2. So in the first shell, the maximum number of the electrons that can be accommodated, they are 2. When n is equal to 2, that is 2 multiplied by 2 square, that is 4, 4 2s are 8. So the maximum number of the electrons present in the second shell, that is 8. Now come to n is equal to 3. So it will be 2 into 3 square. 3 square is 9, 9 2s are 18. And when n is equal to 4, then it will be 2 into 4 square, that is equal to, this is 16 into 2, 32, and so on. Okay, so you can calculate the number of the electrons present in different shells by 2n square rule. This is the first rule. Now the second rule is the maximum number of the electrons that can be accommodated in the outermost orbit, that is 8. Maximum 8 electrons that can accommodate in the outermost shell or the valence shell, not more than that. This is second rule. Now come to the third rule. Very important. Electrons, they are not accommodated in the given shell unless the inner shells are filled. पहले inner shells fill करने हैं, फिर उसके बाद अगले shell पे जाएंगे. This means that the shells, they are filled in a stepwise manner. So these are the 3 rules to accommodate electrons in different shells. So I will take up from hydrogen to calcium, atomic number 1, hydrogen to calcium, atomic number 20, and we will draw the structures of these atoms starting from hydrogen to calcium. You will practice at your own also, because this question is important. Sometimes it's asked that write the electronic configuration of this element, carbon. Okay, so I will take up all these things just now. Now I will draw atomic structures of element hydrogen to calcium. Now first is hydrogen with atomic number 1. this is the nucleus. I am not writing here the number of protons or number of electrons or number of neutrons. I am just drawing the schematic diagrams of different elements. So this is the hydrogen. It has atomic number 1. This means number of electrons present, because atomic number is the number of the protons or the number of the electrons present in the atom. So it is atomic number 1. This means 1 proton and 1 electron. So you will show this electron by, I will show with red pen. This is the electron. So element is hydrogen. Or I may write the symbols. You know the symbols. So I may write symbols, hydrogen, H. Next one is helium. Next is helium. So helium, this is the nucleus again. It has atomic number 2. This means 2 electrons and 2 protons. So in the first shell, I have told you that the maximum number of the electrons that can be accommodated, they are 2. So helium, He, hydrogen, helium. Then comes a lithium. It has atomic number 3. This means electrons and the protons, they are 3. So what do you mean by this? First shell can accommodate only 2 electrons. So the next electron that will go in the second shell. So here you will draw the structure like this. So 2 shells. You will make 2 shells. Okay. So the number of the electrons, lithium, this is lithium, Li, 3, 2 that will be accommodated in the first, and third electron that will go in the next shell or the orbit. Then comes beryllium. Beryllium has atomic number 4. This means it has 4 protons and 4 electrons. So how you will represent? This is the first shell, this is the nucleus, and this is the second shell. So in the second shell, the maximum number of the electrons that can be accommodated, they are 8 according to 2n square rule. Okay. So this is the electronic configuration. You can say this is the electronic configuration. The word is electronic configuration. Means for this beryllium, electronic configuration is 2, 2. Anywhere in the, but on the orbit or the energy level. So beryllium is 4, 2, 2 electronic configuration. First shell 2, second shell 2. Then comes a boron with atomic number 5. This means the electronic configuration is 2, 3. Electronic configuration is 2, 3. In the first shell, the number of electrons that can be accommodated, they are 2. This is the nucleus. And in the next shell, how many? 3 electrons. They will be accommodated. This is boron. 2 and 1, 2, 3. Then comes the carbon. Carbon has atomic number 6. This means electronic configuration is 2, 4. 2, 4. So in the first shell, this is the nucleus, this is first shell, and this is the second shell. So 2 here, 4 here, 1, 2, 3, 4. This is carbon. Okay. Then comes nitrogen with atomic number 7. This means electronic configuration is 2, 5. Okay, 2, 5. Number of electrons 7. Number of protons 7. So next draw. This is nucleus, this is the first shell, and this is the second shell. Circle banana hai apne. You can use compass also. This is nitrogen. 2 electrons in this shell, and then how many electrons? 5. 1, 2, 3, 4, 5. थोड़ा ऐसे फैला के करना है, कई बच्चे साथ साथ ही करते हैं, देखने में नहीं ठीक लगता. ओके, सो नाइट्रोजन, देन कम्स ऑक्सीजन, देन कम्स ऑक्सीजन. Here also first shell, second shell. Clear? Two, now 6. 1, 2, 3, 4, 5, 6. This is oxygen. Then comes fluorine with atomic number 9. This means 9 electrons and 9 protons. So draw. This is the first shell, this is the nucleus, and this is the second shell. Fluorine. So its electronic configuration is 2, 7. 2, 7. 1, 2, 3, 4, 5, 6, 7. This is fluorine. Then comes neon. Neon, helium is the inert gas. Neon is also the inert gas. Means maximum number, it's fully filled. In the same way, neon is also fully filled. The maximum number of the electrons that can be accommodated in second shell, they are 8. So, this is the first shell. This is the second shell. Okay, it should be a clear circle. So, what is the electronic configuration? 2, 8. So, this is 2, 1, 2, 3, 4, 5, 6, 7, 8. This is neon, Ne. Now, next is atomic number 11, sodium. This means it has 11 electrons and 11 protons. Okay, so start making the diagram. This is the first shell. This is the second shell. And this is the nucleus. Protons, they are present in the nucleus. So there are 11 protons present in the nucleus. Now start filling it. Okay. 1 and 2, maximum number. 1, 2, 3, 4, 5, 6, 7, 8. 9th भी यही भर दूं? नहीं. Because the maximum number of the electrons that can be accommodated in second shell, they are how many? They are how many? 8. So I will have to put this one electron in the third shell. So one electron that will go in the third shell. Clear? Now, 12 atomic number, magnesium. Magnesium has 12. Now there is no problem. You will put another electron in the third shell. So this is the nucleus. This is the nucleus, this is the first shell, this is the second shell, and this is the third shell. 3 shells you have to draw. Okay? Clear? You use compass. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. How many left? 2. So electronic configuration is 282 for magnesium. It is 282. Now comes aluminium with atomic number 13. Atomic number 13. So this is the first shell, then is the second shell, and then is the third shell, or the orbit, or the energy level. This is the nucleus. So for aluminium, electronic configuration is 283. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. This is aluminium. Okay? 13. 14. That is silicon. So the diagram is 1. This is the first shell. This is the nucleus, second shell, and this is the third shell. Okay? So electronic configuration is 2, 8, 3, 4, 5, 6, 7, 8, and here 284. Okay, so this is silicon. Then next is phosphorus with atomic number 15. So the electronic configuration will be 285. 285. This is the first shell, this is the second shell, and this is the third shell. This is the nucleus. So how many electrons in the first shell? 2, 1, 2, 3, 4, 5, 6, 7, 8. This is phosphorus. 15. How many left? 5. 1, 2, 3, 4 and 5. Okay. Now next is 16. 16 is sulfur. So first shell, nucleus, second shell, and third shell. So this is sulfur. How many? 1, 2, then 8. 1, 2, 3, 4, 5, 6, 7, 8. So electronic configuration of sulfur is 2, 8, 6. 1, 2, 3, 4, 5, 6. Clear? It's so easy, but it's important. Now come to next 17, that is of chlorine, halogen, fluorine, chlorine. Okay, so this is chlorine. Next is 1, first shell, nucleus, second shell and third shell. So chlorine has electronic configuration 287. This is chlorine. 1, 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. 10 complete. Now 287, 7. 1, 2, 3, 4, 5, 6 and 7. So chlorine 287 is the electronic configuration. Number of electrons 17, number of protons also 17. Okay, जो atomic number है उतने ही number of protons होंगे और उतने ही number of electrons होंगे atom में. Now next is argon. Again this will be filled. 8 electrons that can be accommodated, maximum 8 electrons that can be accommodated here. Okay. 2n square rule that is not followed in the higher elements. Okay. So here what will be the result? Argon 18. 1, 2 and 3. So this is argon, and in this electronic AR, electronic configuration is 288. 18 protons and 18 electrons. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And here also 1, 2, 3, 4, 5, 6, 7, 8. So here also this is completely filled and it's very stable. Inert gases, they are very stable because their outermost shells, they are completely filled. Now the next one is atomic number 19, that is potassium. So what will be the result? It will be having the here that is not followed. First shell has 2 electrons. Okay, first shell 2, second also 8, 1, 2, 3, 4, 5, 6, 7, 8. Third shell will also have 8. In your book, up to argon, structure of argon, that is given, but I am telling you potassium and calcium also. 1, 2, 3, 4, 5, 6, 7, 8. And the last electron, that is shifted to the next shell. Okay, that is shifted to next shell. Here we will explain, I will tell you in detail about this thing in your higher classes. You must memorize this thing, that here the one, after this argon, the one electron which is left, it will occupy, or you can say accommodated, in the next shell. So this is the structure of potassium. Then comes the calcium. Then comes calcium. This is 1, 2, 3 and 4. Clear? So this is calcium. First 2, second 8, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it has atomic number 20. Okay, 20. So its electronic configuration is 2882. So in this last shell, the 2 electrons, they will be accommodated. So I have told you, in your book it is up to argon, there is no problem in the 2n square rule, but here in the case of potassium and calcium, after 8 electron, the remaining electron, 1 in the case of potassium and 2 in the case of calcium, they will be accommodated in the 4th shell. Okay, this thing you must remember. So this is very important. I have told you how to draw the structure. You know that in an atom there are 3 particles: protons, electrons and neutrons. I have told you that the number of the protons and the electrons, they are equal in an atom. And the protons, they are present in the nucleus, and electrons, they revolve in the orbits. Protons are positively charged and electrons, they are negatively charged and revolve in the orbits. So about the neutron, that how we can calculate the number of the neutrons which are also present in the nucleus of an atom and which contribute mass of an atom, that I will tell you later on. So with this, my video, that is complete. So I will meet you in my next video and take up the topic valency. Till then, thank you very much.